Will the silkworm be the next superhero of Marvel Studios? I am Enrique Casanova, and in these next 5 minutes I'm gonna tell you why it will. But first of all, I would like to introduce you a little bit of my PhD project. I am working in the cardiovascular stent field, as my research group is pioneer in the fabrication of cardiovascular stents. We have developed a system that can 3D print a cardiovascular stent customized for a patient in PLA, so a polymeric, a material that can degrade within the body. The bioresorbable cardiovascular stent is in a growing market as they provide an ideal solution for a very common problem. When you have a heart attack, the artery collapses, and then, if you survive, they perform you an angioplasty. After this angioplasty, the ideal solution would be to introduce a cardiovascular stent to maintain the artery structure only the time that the artery is injured. That is why the theoretical solution of the cardiovascular polymeric stents is ideal, also because the transition from the forces that the stent sustains to the artery is gradual. But current polymeric stents has a very common problem, which is low mechanical properties compared to the metallic stents. These weak mechanical properties affect on the design, resulting into a design which is bulkier, bigger. This has problems because it may induce a change of the from the laminar flow from the bloodstream to a turbulent one, which consecutively can induce to vessel occlusion again, which is not wanted. Also, these bigger designs have difficulties in accessing small vessels. That is why this issue should be addressed. And here in the GREP group, we propose the silk from the silkworm. And that is why we think of the silkworm as a superhero. It is known that silk has higher mechanical properties than the polymers currently used for the polymeric stents that we can encounter in the market, such as PLA. Additionally, silk is a biocompatible material which can be biodegraded within the human body, which has been shown that has non-thrombogenic properties, and also it has been FDA approved for medical devices. That is why we have adapted the system of the 3D printing solution in order to 3D print a bio-ink based on high concentrated silk fibroin, which can 3D print a silk based cardiovascular stent in less than 5 minutes. This solution is very complete because not only we can adapt the morphology to the vessel diameter or shape, but also we can also tune the mechanical properties that the stent will have or the degradability rate, as we synthesize the bio-ink here in the lab based on a protocol that is found in nature. We have adapted the protocol in order to concentrate this bio-ink in very high terms, and then we 3D print it by doing the liquid to solid transition, only applying temperature and shear stress. That is why we think that implementing this system next to the surgery room will have a very promising opportunities for the patients that will enter the room, and in less than 5 minutes will have a customized biomedical cardiovascular stent for their own arteries designed for them. And so after the occlusion, the stenting could be done correctly. That is why, if you don't want to worry of Hulk having a heart attack, please help the silkworm to join the Marvel superheroes, and so the silkworm with its silk will be able to create stents for Spider-Man or any other person in the world. Thank you.